It's a nice day, and you're walking over to meet your friend. But before you reach your friend, you'll have to walk half the distance to your friend. And before you walk half the distance, you'll have to walk 1/4 the distance. And before you walk 1/4 the distance, you'll have to walk 1/8 the distance. Before that, 1/16 the distance. Before each mark, you'll have to walk half the distance to that mark. And this can go on forever. In other words, before you reach your friend, you'll have to complete an infinite number of tasks. How are you going to do that? And since there are an infinite number of them, there's no first task. How can you even begin your journey? As you ponder this, somehow, miraculously, you reach your friend. And although your head's in the clouds, your friend really wants to race. Now, let's be honest, you're way faster than your friend, and this isn't a great matchup. So you decide to give your friend a head start. You both start running the race, knowing you'll quickly catch up to your friend. Thing is, by the time you've covered the distance between you and your friend will have ran a little more. And once you make up the new distance between you and your friend will have ran a little more. Once you cover that distance, your friend will have run a little more again, and so on forever, and you'll never win the race. Despite realizing this, you pass your friend and win. And although your friend is a little discouraged, they still would like to hang out with you and pass a ball around. And as you throw the ball back and forth, you get a nagging feeling. Although the ball you throw is clearly in motion, at any instant in time, it's not. If we were able to take a snapshot of any instant in time, we would see the ball is not moving from anywhere and not going to anywhere. At every single instant of time, no motion is occurring. Yet time is entirely composed of instants. And if everything is motionless at every instant, how can motion happen? These are Zeno's paradoxes, and are still somewhat debated in modern times. How do you think we can resolve them? This being a math channel, maybe I'm a little biased, but I believe the hidden mathematics resolve these paradoxes. In our first problem, we had to walk half the distance to our friend, but before that we had to walk 1/4 of the distance. Before that, 1/8 of the distance, and so on. We can write this list as a sequence of numbers. Each number represents a task, a distance we have to walk, in order to complete our journey. Our journey can be represented by adding up all of the tasks, summing these numbers. Problem is, there are an infinite number of them. Fortunately, calculus comes to the rescue. This is what's known as a convergent series. There's a variety of ways to find the value of this sum, but this one happens to be a geometric series which has a very nice formula, and we can compute its value, which happens to be finite. Of course, we knew the value would be 1 just by looking at the distance we had to walk. Our one journey walking to our friend is composed of half that journey, 1/4 that journey, 1/8 that journey, and so on. There is one overall journey, so of course this sum should be 1. Admittedly, this argument might not fix every issue from each paradox, but I think this is a fairly comfortable resolution since we've shown just because an event can be broken down into an infinite number of tasks, that doesn't mean the event itself is infinite.